Welcome back to our factoring series. This video is about how to use the AC method, which is going to be great for those of you that are good with pattern recognition. So let's get started. In order to use this method, we need to be able to add and subtract polynomial expressions, find factor pairs, and you need to be very strong with your factoring by grouping. If you are not, then take a moment, go back, and review the methods, okay? Pause the video and complete this table. Restart when you're ready. Okay, so here are my solutions. When we multiply two binomials, we expand to get four terms, and then we simplify. How do we go from the simplified expression, the three-term expression, back to the products? Well, what we do first is we rewrite our trinomial with four terms, and then we use the factor by grouping method. I think that this is such a mathematically elegant way to factor trinomials. It's one of my favorite things to teach. Okay, so how do I use this method? So the strategy itself is simple. We can rewrite our trinomial with four terms, so we can factor by grouping. By splitting our middle term into two pieces, we basically make our trinomial into a quadrinomial. And then we can use some of the other methods that we know how to use. Let's factor 8k squared minus 6k plus 9 using the AC method. I look for a GCF first, and since I don't see one, I'll make sure that my polynomial is in standard form, which it is. So now I'm going to multiply my first and last term. So 8k squared times 9 gives me 72k squared. Now I need to split my middle term, so I need two terms that sum to negative 6 and multiply to 72k squared. Negative 6k. Negative 12k and 6k will work, so I am going to split my middle term. Now, if the signs are correct, it doesn't matter what order I use to split them. Okay, so I keep my two other terms on the outside, and negative 6k becomes negative 12k plus 6k. Then I'm going to factor the expression by grouping. I'll add in a bar. 4k comes out. I'm left with 2k plus 3. 3 comes out, and I'm left with 2k plus 3. Finally, I bring down my binomial, left with 4k plus 3, and I'm fully factored. Let's factor 6h squared plus 17hk plus 10k squared. Now, as always, I look for my GCF. I don't have one, but I do notice that there are two variables in this expression, so standard form should have your highest powers on the first and last terms. Okay, so it's in standard form. I'm going to multiply 6h squared times 10k squared to get 60h squared k squared. I now know that I need two terms that sum to 17hk and multiply to 60h squared k squared. 12hk and 5hk work, so I'm going to leave my 6h squared and 10k squared on the side, and I'm going to split my 17 into 12 and 5. Okay? I put my bar in, factor on the left, 6h comes out, leaving h plus 2k. On the right, 5k comes out, leaving h plus 2k, and I can bring down my binomials, and I'm fully factored.
I need to factor 6u squared v minus 11u squared v squared minus 10u squared v to the third. Okay, clearly GCF alert. Let's take the u squared v out first, and then we're going to look and make sure everything's in standard form. So inside the parentheses, notice that I have my highest power last and my lowest power first. That's perfectly fine for the grouping method, okay? The most important thing is that the second term is the correct one to split. After I multiply 6 squared and negative 10v squared, I know I'm looking for two numbers that sum to negative 11v and multiply to negative 10v squared. Okay? 4v and negative 15v will do nicely. I keep my u squared v outside, and I split that middle term, and now I'm ready to throw in my bar and group and factor by grouping. So I'm left with u squared v times 2 minus 5v times 3 plus 2v, and I'm done.
Okay, so today we learned how to rewrite trinomials using the grouping method, otherwise known as the AC method. This is one way to factor a non-perfect trinomial. We're going to learn 2 more ways, but it's important that you kind of give all of these a chance, learn all of them, and then decide which one feels most comfortable, and then you can use that method going forward. Up next, another method for non-perfect square trinomials, the box method.